Welcome. Today we're going to be working on 14a, which is solving equations with variables on both sides. This is day number 2, so we did work on this in our previous lessons. So first things first, let's go over our content objectives. Students will be able to solve equations that have variables on both sides, and they'll also be able to check their work, their solutions. Language objective, students will be able to state the mathematical properties used when solving equations. And why am I learning this? Well, it's important for real life problems like finding out which cell phone plan is a better deal. So first things first, we're going to go over some background knowledge. The only thing I want you to recall from this slide is the fact that we have here what we would call a one solution. Okay, the only solution that would work for this equation where it would lead me to a true statement is x equals 13. So again, this is one solution. Now, looking at our 8th grade standard, it states that we need to be able to give examples of linear equations in one variable with one solution, infinitely many solutions, or no solutions. So in the previous example, that was an example of a one solution. Okay, x equals 13. That was the only value for x that would work. Now, you also need to be able to show which of these possibilities is the case by transforming the equation into a more simpler form, okay? Until you get an equivalent equation, either in the form of x equals A equals A, or A equals B, okay? In this case, where A and B are different numbers. So with that note, let's go ahead and jump into our first example here. Just remember, the idea behind solving any equation is to try to find the numerical value of the variable that creates a true statement. So just let's focus on that. So here, let me solve this one real quick. I have 9x minus 15 equals, distribute that, I get 9x minus 15. Since I have variables on both sides, I'm going to go ahead and move it over to the left. So subtracting 9x from both sides, I'm left with negative 15 equals, negative 15. Well, when solving this equation, what was different about it? Well, I'm not sure if you noticed, but I don't have a variable anymore. It was eliminated. So what this means is any value for x will make a true statement. No matter what number I plug in, it will work. So real quick, let me give you an example of that. So here, if I write down the equation, except for when I see a variable, I'm going to leave a blank spot with parentheses so that I can plug some values in. You're going to notice that I can plug different numbers. So here, let's try 0, because 0 is an easy number. Okay, here we get 0 minus 15 equals, and here we have to do what's inside first. 3 times 0 is 0, minus 5 is negative 5, so it's 3 times negative 5. I get negative 15 equals negative 15. Perfect. Now, let's try another number. Let's try maybe 1. 1 seems to be a pretty easy number. So here, now I'm going to go ahead and try the number 1. So here, let's put a 1, another 1 here. Here we have 9 minus 15 equals, here you have to do what's inside the parentheses first, that's 3. 3 minus 5 is going to be negative 2, so 3 times negative 2. Here we have a negative, 6 equals a negative 6. So notice, x equals 0 worked, x equals 1 works. So there's many different values that for x that will make a true statement. Here were just a couple of examples. So now, let's see. The other thing is I want you to understand when this is the case, we should say that the solution is infinitely many solutions. That's what you would write as an answer on your quiz, on your homework, on a test. Okay, your answer is going to be infinitely many solutions. Perfect. So I'm just moving on. So what do equations look like when we have infinitely many solutions? Well, Remember, when we simplify this, we got 9x equals 15 equals 9x, so we distributed the 3. I hope you can see at this point that we have equivalent expressions, okay? So this expression is equivalent to this, but most importantly, 9x minus 15 is equivalent to 9x minus 15. So if you keep solving, okay, you would end up like I just showed you in the previous slide, basically 0x minus 15 equals negative 15, but we really don't write the 0x, so it's negative 15 equals negative 15. So equations that end in the form of a equals a will always result in infinitely many solutions. So another way of thinking of it is when the variable gets eliminated, okay, and the end is a true statement, such as this is what we would consider a true statement, then we know that there are infinitely many solutions, okay? So there's two ways to think of it. You could think of it where the equation is in the form of a equals a, or you could think of it in terms of did you end up with a true statement? But this only occurs if our variables are eliminated, okay? Because if they're not eliminated, then we end up with one solution. The next example, let's see here. I'm going to have 9x minus 14 equals, distributing the 3, I have 9x minus 15. Here, since I have variables on both sides, I'm going to go ahead and move it over to the left. So I'm going to go ahead and subtract 9x from both sides. This is going to leave me with negative 14 equals, this is going to cross out as well, negative 15. Well, here, what's so different about this equation? Once more, I have no variables whatsoever. They were both eliminated from both sides, and I ended up with a false statement. So what does that mean? Well, it means that there is absolutely no value for x that will make this a true statement. Unfortunately, I know that in class I always ask you to check your work. That way you know that you have the correct answer for the equation. However, when we have this case, which our variables are eliminated and we end up with a false statement, since there is no value for x to make it a true statement, I can't substitute anything in to see if it really is the case. So here, what you would say as an answer is there is no solution. So this is the one exception where you can't really check your work because there is no solution that will work, okay? So here, what do equations look like that have no solution? Well, in the previous slide, I did work this problem out, and when I distributed the 3 over to both terms, I ended up with 9x minus 14 equals 9x minus 15. Here, you can see right away that these expressions are not equivalent. 9x minus 14 is not the same as 9x minus 15. So essentially, if you were to keep solving like I did in the last one, we ended up with negative 14 equals negative 15, which is a false statement. That is not true. So when we get equations in the form of a equals b, just meaning they are different numbers, okay, then your answer will always be no solution. Or in other words, you can say if the variables are eliminated, like they were in this case, okay, so just to prove my point, subtracting 9x from both sides, they were eliminated here, then if you end up with a false statement, then the answer will be no solution. So quick recap, if we get a equals a, that's infinitely many solutions, okay? However, if we end up with a equals b, that is no solution. Okay, but let's not forget the very first one, which is x equals a. Basically, this means the variable equals one number. This is a one solution. So these are the 3 types that we're going to be working on from now on. There are 3 types: a one solution, infinitely many solutions, and no solutions. Okay, so looking at our very first example, what we're going to do is go through the same routine like we normally do. Check to see, can we distribute? The answer is no. Can we combine like terms? The answer is yes. So I'm going to go ahead and combine like terms from both individually on both sides, and I'm going to end up with 10y minus 8 equals 10y minus 86. How did I get this step? Because I'm asked to justify. Well, I got this step by combining like terms. Now, before we move on, what I'm going to ask you to do is take a look at what we have right now. 10y minus 8 equals 10y minus 86. I want you to predict, do you think this is going to be one solution? Do you think this is going to be infinitely many solutions, or do you think this is going to be no solution, and why? Well, let's go ahead and finish solving. Here I'm going to subtract 10y from both sides, leaving me with negative 8 equals negative 86. I did that by using the subtraction property of equality. Why, you might ask? Because I subtracted 10y from both sides. Now at this point, I can see clearly that it's in the form of A equals B, which means that I have a false statement. So my final answer, what I would write down in my homework and circle as the answer, is I would say there is no solution. So what does that mean? That means there's absolutely no value I can think of or dream of for y that would make this a true statement, because it does not exist. There is no number. Okay? So keep that in mind, that if you end up with a false statement, or basically have the form A equals B, then the answer is no solution. So make sure on your homework you're not writing false statement as an answer, because that's not an answer. The answer is no solution. Quick look at our next example. Here, going through the normal steps, I'm going to check if I can distribute. Nope. I'm going to check to see if I can combine like terms. That I can do, so I'm going to go ahead and do that. I'm going to be left with negative 3x plus 4 equals negative, I'm sorry, I read that wrong. Negative 3k plus 4 equals negative 3k plus 4. I got this step by combining like terms. Now, before I move on, I'm going to take a look at my expression here. I want you to predict, okay, just by the looks of it, what our answer is going to be. Okay, so now let's go ahead and do what we normally do and understand that since we have variables on both sides, I'm going to go ahead and move it over to the left. I'm going to do that by adding 3k to both sides. I'm going to notice that they cancel each other out, leaving me with 4 equals 4. And the way I got to this step was by adding to both sides, so I use the addition property of equality. So notice, after every single step, you should be justifying what you did to get that equation. So here, this is in the form of A equals A. This is what we would consider a true statement, because 4 does equal 4. So here, my final answer would be infinitely many solutions. Okay, whoops, we forgot a S right here. So make sure you put an S. Infinitely many solutions. So, what does this mean? Well, it means that there is more than one value for, in this case, k, that would work. So let me prove it to you. Here, what I'm going to do is plug in different values for k to show that there's more than one. And the fact that I can prove that there's more than one is definitely no solution. So here, let's try k equals 0. The reason why I'm choosing 0 is because 0 is easy. So here, I'm going to plug in a 0 for all of my variables. So I'm left with 12 plus, this is going to be 0, minus, this is going to be 0 as well, minus 8 equals, here that's 0, minus 15 plus 19. So here, this is nothing, so 12 minus 8 is 4. Here, negative 15 plus 9 is 4. That works. Now the true test, what about k equals 1? K equals 1 because 1 is another number that I can plug in, and that's going to be easy to multiply and figure out. So here I'm going to get 12 plus 3 minus 6 minus 8 equals negative 3 minus 15 plus 19. 12 plus 3 is 15, 15 minus 6 is 9, 9 minus 8 is 1. Here, negative 3 minus 15 is negative 18, negative 18 plus 19 is 1. So notice we have k equals 0 working and k equals 1 that also works. So here is proof that there's more than one solution. Because there's one solution, there definitely cannot be no solution. So there are infinitely many solutions. So what does this also mean? It means any number you plug in for k will make a true statement and will be a solution. K can equal 1,000. K can equal 1/2. K can equal -3. It will always give you a true statement, which means it's a solution. So now let's move on to our next example here. We're going to go through our normal steps just like usual. Can I distribute? Yes, I can. So I'm going to go ahead and do that, and I'm going to be left with 3x plus 8 equals 2x plus 8 plus 2x. So how did I do that? Well, I got this equation by using the distributive property. Now the next thing I'm going to check to do is, can I combine like terms? The answer is yes. So I'm going to go ahead and do that. I'm going to end up with 3x plus 8 equals 4x plus 8. And how did I get this step? Well, I combined like terms. So now before we move on, I want you to think. What do you think the answer is going to be? Do you think it's going to be one solution? Do you think it's going to be infinitely many solutions? Or do you think it's going to be no solution? Okay, so let's go ahead and try and figure this out. Well, since I have variables on both sides, I'm going to go ahead and move it over to the left by subtracting 4x from both sides. I'm going to be left with negative x plus 8 equals 8. And I got to this equation by using the subtraction property of equality. Now, what am I going to have to do? Well, it seems like I'm going to have to get rid of my constant, so I'm going to go ahead and subtract 8 from both sides. And that's going to leave me with, negative 1x equals 0. Yes, because these eliminated, there is a 0 there. Now, how did I do that? Since I subtracted 8 from both sides, I'm using the subtraction property of equality. Here's where some of my students go astray. For some strange reason, they think, oh, I see a 0, so there must be no solution. How? The only way you end up with no solution is if you get the form A equals B, or in other words, a false statement. Is this a false statement? The answer is no. The real fact of it remains that you're not done. If you divide both sides by -1, you end up with x equals 0. You actually have an answer. This is a one solution. Oh, and sorry, I forgot to mention, here I got to this step by using the division property of equality. So, key thing you need to remember is this. Please do not jump to conclusions too quickly. Finish through your work and see what the real answer is, because a lot of you will make this mistake and you're going to feel silly for it later. So let me check my work. I'm going to go ahead and rewrite this equation using parentheses, but I'm going to go ahead and plug in a 0. So we have 0 here, 0 here, and 0 here. 3 times 0 is 0. 0 plus 8 equals, here, since I have parentheses, I have to work what's inside parentheses first. 0 plus 4 is 4. 4 times 2 is 8. Here it's 0. So 0 plus 8 is 8. 8 plus 0 is 8. So it checks out. Okay. So now moving on to our next example. Now, without solving completely, I want you to determine whether the solutions are going to be one solution, infinitely many solutions, or no solution. Kind of like how I was stopping you midway as we were solving. I was trying to get you to see, what do you think the solution is going to be? This is what you're going to do now. So go ahead and pause the video and try this one on your own. Okay, so now we're back. So let's discuss what we have here. For number 4, I'm just going to simplify real quick. By distributing, I'm going to be left with 6a minus 3 equals 6a minus 3. These expressions are equivalent. So I would say that the answer is infinitely many solutions. Okay, so now let's look at number 5. I have 5m plus 2 equals 3m minus 8. I'm hoping that you recognize from the examples with infinitely many solutions and no solution, our variables always eliminated. By the looks of this, 5m and 3m aren't going to eliminate each other. So guess what? I'm going to say that the answer is going to be one solution. Hopefully you got that one right. For number 6, well, I can see that 5y minus 2 equals 5y. These they will definitely eliminate each other, but these expressions aren't equivalent. So the answer is no solution. Number 7 is a little bit tricky, but hopefully you can recall how you would take care of something like this. This basically means 3x over 3 minus 12 over 3. Okay, so the 3 is written under each term. And this is going to basically simplify to x minus 4. So if we replace this with x minus 4, the variables are definitely going to eliminate each other. However, these expressions are not equivalent, which means this is no solution. Now for number 8. What I would do here is go ahead and simplify. I'm going to end up with 18x minus 5. Here it's going to be 12x, but 12x plus the 6x here is going to give me 18x. 3 times negative 1 is negative 3. Negative 3 minus 2 would be negative 5. Guess what? My variables would definitely eliminate each other since they're the same. But these expressions are equivalent. So I know for sure that my answer is going to be, hopefully you guessed it right, it's going to be infinitely many solutions. So quick recap. If you notice your coefficients are the same, they're going to eliminate each other. Okay, which means if the expressions are equivalent, you have infinitely many solutions. If you have different expressions, but you know that your coefficients are the same, you would end up with no solution. Okay, so just try to keep that in mind as you're working on homework, quizzes, and tests. Now for number 9, what you're going to do is I'm going to give you a list of expressions, and you're going to try to figure out if it's one solution, no solution, or infinitely many solutions. So here they are. Go ahead and pause the video and try this one on your own. Okay, so we're back. So for the first one, if we have 24w minus 72, which one would it be? Well, real quick, let's figure what this is. It's going to be 24w minus 72. Well, the variables are the same. The coefficients are the same, I mean. So guess what? These are equivalent expressions, so I'm going to say number 1. I would be C, infinitely many solutions. Okay, so let's try the next one. Here, it's going to be 24w minus 72. Once again, the coefficients are the same, and my expressions are equivalent, so this is going to be infinitely many solutions. The third one, let's see here, we have 24w. 2 times negative 5 is negative 10. Negative 10 plus 12 would be positive 2. Here my coefficients are the same. However, these expressions are not equivalent because this is minus 72 and this one's plus 2. So that means it's no solution. Okay, moving on to the fourth one. Here we have 3w minus 9. Guess what? Our variables, not variables, our coefficients don't match. So guess what? It's automatically one solution. Okay, the only way we can get to these choices is if our coefficients are the same. Okay, so since they're not, automatically one solution. Now here, let's do our very last problem. We have, let's see, 7w with a positive 17w gives me 24w. A negative 14 with a positive 44 would leave me with a positive 30. So here, the coefficients are the same. So we're thinking either no solution or infinitely many solutions. Since these expressions are not equivalent, I would say it's no solution, so that would be B. So hopefully your answers match mine. If not, please make them match. So moving on to our very first word problem. It says here, you can buy a skateboard for $60 from a friend and rent the safety equipment for $5 per hour. Or you can rent all items you need for $5 per hour. For how many hours will the cost be the same? So hopefully you are recognizing that they're asking us for how many hours will the cost be the same. So first things first, since they're asking us for how many hours, I'm going to go ahead and let H represent the number of hours. Okay, so whenever you're picking your own variable, you should be identifying to the person or whomever what your variable is representing. So that's why we have the statement here. Now let's go ahead and make an equation. Since it's $60 plus the $5 rate for the safety equipment, it's going to be 60 plus 5H. And then here for renting all of our equipment, since it's $5 per hour, that's going to be 5H. Notice I did set them equal to each other. Why? You might ask, well, they're asking me when's the price going to be the same. So that's why I went ahead and put an equal sign. Now, just for a second, I want you to think about common sense. If you're getting charged $60 for a skateboard and then $5 for renting this stuff, okay, that's one situation. In another situation, you are only getting charged $5 an hour for renting the safety equipment. When will the cost ever be the same? Well, let's see. Hopefully you have an idea right now. So here, let me prove it to you. Since I have variables on both sides, I'm going to go ahead and subtract it over to the right this time, actually. Because if I don't, I'm going to get a 0 on that side. So I'm going to go ahead and do that. I'm going to subtract 5H to both sides. So notice I'm moving it to the right this time. Otherwise, I would end up with 0. But watch what happens. No matter what I did to prevent it, I'm still eliminating both of them. Okay? And which leaves me with 60 equals 0. That's a false statement, which means there is no solution, which means the cost will never be the same. And hopefully when we got to this equation right here, you were able to figure out, yeah, it's never going to happen, because if you're getting charged $5 per hour for safety equipment in both cases, but in one case you have to buy the actual skateboard, automatically that one's going to be more expensive. So there's no way the prices will ever be the same, since the rates are the same, but one has a higher constant. So now, let's try the next one. Okay, so here it says, a hairdresser is considering ordering a certain shampoo. Company A charges $4 per bottle plus a $10 handling fee per order. Company B charges $4 per bottle plus a $10 handling fee per order. For how many bottles will the cost be the same? So I'm going to go ahead and let B represent the number of bottles, because that's what they're asking me for. Now the next thing is I got to figure out an equation. So for company A, I'm going to go ahead and set the expression as 4B, because it's $4 per bottle, plus 10, because you're going to get charged this handling fee. For company B, I'm going to put 4B, because it's $4 per bottle again, plus 10. So this is what I end up with. And notice I did put an equal sign. Why? Because they're asking me when the cost is going to be the same. So now I want you to just pause for a second. I want you to think. If company A is charging you $4 a bottle plus a $10 handling fee, and company B is also charging $4 per bottle and a $10 handling fee, when will the cost be the same? For how many bottles? Well, let's see. Since I have variables on both sides, I'm going to go ahead and move it to the left by subtracting 4B from both sides. They eliminate each other, and you end up with 10 equals 10. Since this is a true statement, the answer is going to be infinitely many solutions. What does that mean? That means the cost will always be the same. If you think about it, since they're charging the same rate and they have the same cost for a handling fee, they're essentially charging the same every single time, no matter if you buy one bottle or two bottles. So let's see. Let me give you a quick example. For company A and company B, okay? If for company A, let's just buy one bottle of shampoo. That's going to be $4 for that one bottle plus 10. So that's $14. Well, what about company B? Again, since you bought one bottle, that's $4 plus 10 for the handling fee. It's going to be $14 as well. But let's go ahead and try a different option. What if you wanted to buy, here's one bottle. What if you wanted to buy 10 bottles? I'm choosing 10 because it's easy to multiply by 10. Company A, well, since it's $4 per bottle, that's $40. But plus the handling fee of $10, it's going to cost $50. Well, what about company B? Well, again, since they are charging $4 per bottle, 10 of them would cost $40 altogether. Plus that $10 handling fee is going to cost you $50. So notice it's going to cost the same for one bottle. It's going to cost the same for 10 bottles. In fact, it will always cost the same no matter how many bottles you buy, because there are infinitely many solutions, okay? So before we finish, I want to do a quick recap, okay? If you end up with A equals A, that is a true statement, which means there are infinitely many solutions. And what that means is there's so many solutions that would make a true statement. Okay, any number you can pick under the sun would work. If you end up with A equals B, which is a false statement, okay, then that would mean there are no solutions, which means there's absolutely no value for your variable that would make a true statement. Nothing. And last but not least, if you get x equals a, meaning you get the variable to equal a number, okay, then you're going to end up with one solution. This is the one that we've been working on for a long time now. We've always worked with one solution. These are the new ones, okay? So taking another focus on these two, okay, I'm going to write it right here. Essentially, if the coefficients are the same, so for example, 7x plus 3 equals 7x plus 3, since the coefficients are the same and the expressions are equivalent, the answer would be infinitely many solutions. But what if you had one where the coefficients were the same, but the expressions were not equivalent? Okay, so again, these coefficients are the same, but the expression is not equivalent, then you would lead to no solution. So the only way you can get into any of these is if the coefficients are the same, because that's the only way they can eliminate each other. Okay, so I want you to keep that in the back of your mind. Hopefully that's going to help you solve these equations a lot quicker, but never jump to conclusions, especially when you see a zero. A lot of students like to say it's no solution, but if you work it through and use the facts that we've learned today, you're going to be able to come to an accurate conclusion. So hopefully this lesson has helped. Thank you for tuning in. Until next time, bye.